Okay, let's look at this example here. Let's say there's a 2D object. Okay, 2D, I mean this is a 3D object, cuboid and cuboid. Now, scale factor is more powerful than if you do it individual. Okay, let me explain how you can use the scale factor rather than finding out all the length. Now, first of all, how do you define scale factor? Scale factor is basically a fraction. It's a fraction, okay, of the length. Okay, why linear? Because it's only one direction. So a scale factor, if you compare this and this, then you must find the corresponding length, which is I and j. So the scale factor in this case is 2/5. Okay, now, so this become 2/5. These are given. Okay, now, for example, if I give this is 7, then what would be this length? Remember, this BE versus IJ is also the corresponding length. That means if you take, you see, you start out with the small over the big one. So you take BE or the big one, you still get the same ratio. In other words, BE or IJM, you still get the same scale factor if these two 3D objects are similar. In other words, you can actually put them together. Since they are the corresponding length, the bigger length are the smaller length on top. Okay, the smaller length is the smaller length on top. The smaller length is JM, which is at the denominator. Okay, you see, you define it as the smaller length over the big length. So similarly, on these two sides, the smaller length is up here, the bigger length. So this R is JM. So the length would be, this will give you GM equal to 7 times 5 cross multiply divided by 2. That will give you 17.5 cm. Okay. Now, I mean, beside using the scale factor to find the unknown length, you can also use to find the area. Now let's look at this. For example, let's look at given ABCD. Okay, area ABCD is 20 cm square. I want you to find out the area of the corresponding area, which is IJKL. This is the area of IJKL. So area IJKL. Okay, this is given ABCD. You are supposed to find this. Okay, now if I do not give you the height, okay, of this surface, then practically you cannot find the height of this. So you cannot, in this case, you cannot calculate the area and find the ratio between this area over this if you are not given the height. But then using scale factor, I will be able to find the area of this. You just watch. Okay, now if you compare area, if they are similar, then the scale factor, when you want to compare the area, is a scale factor square. You square the scale factor. Okay. Earlier, when you're given 2 and 5, you already find the scale factor, which is 2/5. Now, even though I am not given this length here in order to compare the area, but if I use a scale factor, I can find this area. Now, so therefore, if this area, then the ratio is actually equal to scale factor square. So in other words, the scale factor is 2/5. So it's 2/5 square, which give you 4/25. Okay, so cross multiply the area of I J K L is equal to cross multiply 20 times 125 over 4. 5 here, so give you the answer of 125 cm square. See, we do not need to find the length of this in order to find the area. You do not need. If you use the scale factor square and one area is given, the other similar area, you can use the scale factor square. Okay, now let's look at volume. How do you compare the ratio of volume? If let's say the volume of this whole thing, okay, is equal to let's say it's 750 cm cube. Now I want to find the volume of the large cube. Okay, volume of the large cube. Cuboid. Okay. Now, if you want to compare the volume, you have to cube the scale factor. In other words, you 205, you cube it. Okay. So, to find the volume of a large cuboid, what you do is you cross multiply again, but remember this is scale factor cube. So in other words, is actually if you cross multiply, then is 5 to the power 3 times 750 and then divided by 8. That means this 2 to the power 3. Okay, this 2 to the power 3. Now, so from here, 125 times 750 divided by 8. So, if you use calculator, okay, now you can see you don't even need to know the height, the length, okay, of the two cuboid. What you need is only one corresponding pair, the ratio, the scale factor of one pair of length. So if you are given the volume of this, you just cube the scale factor. Then from here you work out. Now, similarly, if you want to find the area, if you are given this area, for example, this is 20 cm here, you just need to square the scale factor and cross multiply, you're able to find the area of this side. You can see that you do not need to find the length, this height here for this surface. Similarly, you do not need to find the length of the cuboid in order to compare the volume if you use the scale factor. Okay, so that is the point when I send you the video, so that you will understand how to use scale factor to do the calculation.